Yes, very good morning, students. Hope I am audible.
Good morning, sir.
Morning, thank you. Okay, just without much delay, let me continue what I was discussing. So, yesterday I was discussing about the statistical characterization of the correlator outputs, right? So, I said the output of the correlator is characterized by its mean and variance, right? So I said the xj, capital Xj, is a random variable which is characterized by its mean and variance. Similarly, the Wj is also a random variable and which is characterized by its mean and variance. And I said by definition, the white noise is having zero mean and a power spectral density of n0 by 2. With that, I said what is the mean of the random variable xj, right? So I define the mean of the random variable xj as mu suffix xj is equal to, we write e of xj, so which is equal to e of, I substitute the value of xj as sij plus wj, and we know the value of wj is 0, means the mean of the wj is 0, hence I wrote mu xj is equal to sij, right? So we were there till that. Then the next step is finding the variance of the random variable xj. Okay, so let me start with that. Hope you are able to see the Word file.
Yes, sir.
Yeah. Okay. As I said, the variance of the uh, random variable xj is defined like this. So it is denoted like this: sigma, right, square xj, which is equal to variance of xj. We write. So we know what is the variance of xj can be written as expectation operator of e of somebody as yeah, fine. So it is xj. I think somebody should unmute. Somebody is, I think, mute. They have unmuted. Xj minus Sij. Sorry. Yeah, can be Sij. Square I can write. Okay. Variance of Xj will be equal to expectation value of Xj minus Sij whole square. Okay. Is this fine?
Yes, sir.
Yeah. And what is Xj? It is Sij plus Wj, right? Yes, I'm asking, Xj is Sij plus Wj, right? If I substitute that, what happens? Minus Sij plus Sij will get cancelled. What will be left out? Only E of Wj. Okay, Wj square is left out. Hope you're understanding how I wrote Wj square, because Xj here you can note, because I said Xj xj is equal to what I said? It will be Sij, right? Sij plus Wj. Oh, sorry. Let's come here. Okay. Yeah. Yes. Let me write here why I wrote. So I said xj is equal to Sij plus Wj. Okay. So if I substitute here xj as Sij, then minus Sij plus Sij will cancel. Only Wj will be there, right? So let me call this as equation 9. This is my equation 9. Okay. So how do I define the random variable Wj? As per the definition, yes, Wj. Okay. Oh, sorry. The random variable Wj is defined as, so Wj will be equal to, it will be equal to what? Integral 0 to t, okay, W of t, uh, yeah, W of t pi j of t into dt. Pi j of t, sorry. Okay, pi j of t into dt is it. So now I can rewrite this equation 9, that is the variance, right? With respect to this, because I know what is Wj. So let me do that. If I move up, is it fine? Okay. Okay, as I said, the equation 9 may be rewritten as okay, the number of pages are more, so it is taking more time to save. Yeah. Can you say equation 9, right? Can be maybe written as equation 9 may be written as I think I will open a new file only. Is that fine? Because here the number of pages are more, so it is taking more time to save. So let me.
Sir, can you show today what you wrote, sir?
Okay. Yeah, I started with defining the variance, definition of variance. Yes, I started from here. Sorry. Is that fine? Okay. So variance I defined. The variance of the random variable xj will be denoted as sigma square xj. So I can write variance of xj. So which is equal to what? Xj minus sij whole square. Okay. So I substitute the value of xj as sij plus wj. So with that sij plus sij and minus sij will get cancelled. Only wj will be there. So I know what is wj, right? I can define the random variable wj as integral 0 to t w of t by j of t into dt. So what I am doing is I am going to substitute this value in this equation 9. Means I need to write e of this one wj square, no? So two times I need to write. Okay. So I think I will close this file because it is taking more time to save. Or I think number of pages I have created more. So with that it is creating trouble. Okay. Let me try. Yeah, what I said, equation 9 can be rewritten as xj. I think better I will stop this. It is wasting time. Okay. Stop thinking. One minute. I will just adjust. I will reduce number of pages. Yeah. Xj square, right? So which is equal to, I'm writing just equation 9. Okay, I'm rewriting that. So E of what is that? Just I'm substituting the value of wj as this integral 0 to t w of t by j of t into dt. So I said I can write twice, right? 0 to t uh, w of t by j of t into dt. Yeah. So one more time I need to reiterate because it is expectation of E of wj square, right? So that into, once again you can write, so 0 to t w of t by j of t into dt. Okay. Is this fine? Just I wrote here, and so what I can do is it is wj square. So I can change the variable. One I can write it as w of t pi j of t into dt. Another one I can take it as another variable instead of t. So let me take another variable. So which may be, I think I can write, replace. So let me write this as w of u. Okay, pi j of u into du I can. Yeah. So two terms I have written, right? One I have taken it as w of t pi j of t, another one w of u pi j of u into du. So I think just rearrange the above equation. If I rearrange, means taking integral one side and writing the remaining terms, and then interchanging the order of integration and expectation operator. So I will be able to simplify this expression. Yeah, I don't know how many of you are familiar with this autocorrelation function. Hope you are familiar with the autocorrelation function. Yes, I'm asking you people only. Are you aware, at least in general, what is autocorrelation function? Hello?
Yes, sir.
Yeah, then it is fine. So 0 to t, so 0 to t, uh, yeah, pi j of t, then pi j of u, mm, then w of t, w of u, dt into du. Okay. So as I said, interchange the order of integration and expectation. Means expectation operator will come inside. Okay. Means integral will be there for this one, pi j of t, pi j of u. Okay. So expectation operator I can write e of w of t, w of u. So if I do that, hope I will not write that sentence because you understand my difficulty in writing. So I will keep only few pages from now onwards. Yeah. Hope you will be noting now interchanging the order of integration and expectation. What we can write is we can write sigma xj square is equal to, so integral 0 to t, then one more integral 0 to t wj of t then wj of u. Then I said write the expectation operator e of uh, w of t, right, w of u into dt into du I can write. Okay. So I can call this expectation of w of t, w of u as the autocorrelation function. Okay. So I can replace that term expectation operator by autocorrelation function. I can add 0 to t, 0 to t, an integral 0 to t pi j of t then pi j of u. So that autocorrelation function will be denoted by Rw of t comma u. Okay, t comma u. That into dt into du. dt into du. So let me call this as equation 10. Okay. So I said Rw of t comma u is the autocorrelation function of the noise process, right? So you may be seeing here only it is E of W of T, W of U. So it is only the noise term is involved. Okay, so it is the autocorrelation function of the noise process, I can say. This one. Okay. Is that fine? So RW of T comma U is the autocorrelation function of the noise process W of T. Just I will write here. What I said, this RW of T comma U is the autocorrelation function. Autocorrelation function of the noise process W of T. So I will not write the word noise process, just I will write W of T. Is that fine? Okay. And this noise, we say it is stationary, right? The noise is stationary, and the value of this autocorrelation function, that is RW of T comma U, depends only on the time difference. So this is important. Okay, as I said, this noise is stationary. This autocorrelation function depends only on the time difference. Please have a note of this. Okay, it depends only on time difference, I will write. Okay, it depends it depends it depends only on time difference. So what is the time difference? Which is denoted as, it depends only on time difference. That time difference T minus U. Okay. And we know this white noise is a constant, right, with power spectral density of N0 by 2, right? So with that, I can write this autocorrelation function RW of T comma U will be equal to okay RW of T comma U, as it is a autocorrelation function, which is equal to, sorry, it is equal to N0 by 2 into del of T minus U, I can write. Okay, so RW of T comma U is equal to N0 by 2 into del of T minus U. So let me call this as equation 11. Okay, so I defined what is the autocorrelation function, because I know the noise is stationary with a power spectral density of N0 by 2. So with that, I can define RW of T comma U is equal to N0 by 2 into del of T minus U. So let me substitute this value in the equation 10. So if I do that, and then if I apply the shifting property of the delta function, so what I can write, substituting the value of this autocorrelation function in equation 10, and then using the shifting property of the delta function, I can write the variance. Okay, I can write, yeah, I can write the variance. So I'm not writing that word, that sentence, whatever I dictated. So please have a note of that. I said substituting the value of this autocorrelation function in the equation 10, and then using the shifting property of the delta function, I can write the variance as, that is sigma square xj is equal to, so shall I write n naught by 2 outside only uh, before the integral. So n naught by 2, okay, n naught by 2, then the rest of the terms. What are the rest of the terms? That is integral 0 to t, then one more integral, right, 0 to t, then what is there, pi j of t, pi j of u. Just I am substituting the value. Okay, so let me, so it is pi j of t, then pi j of u, then I said the r w of t comma u is what, n naught by 2 into del of t minus u, right? Already I wrote n naught by 2 outside, so I can substitute the remaining term, that is del of t minus u here. Okay, and dt into du. Is that fine? Yeah. So what is the shifting property says? Any one of you can say shifting property means if I apply here this pi j of u into del of t minus u, right, into du, because with respect to the variable du if I take, so what is the shifting property? I can say when u equal to t, so I can write based on the shifting property of the delta function, this one pi j of t del of t minus u into du can be written as phi j of u. Okay, so I will just write here. So because of this shifting property, okay, so pi j of u into del of t minus u, sorry, yeah, del of t minus u. Okay, so that is integral 0 to t into du will be equal to, I can say it is pi j of u, will be equal to pi j of u. Okay, so this is when you can say u is equal to t. So when u is equal to t, I can write it as pi j of t. Okay, if I substitute u equal to t, then I can write it as pi j of t. Fine. So means this integral pi j of u del of t minus u into du will be equal to pi j of u, you will get. this term. And if I substitute u is equal to t, I can write as pi j of t. What I mean to say here is I can replace the second term pi j of u del of t minus u into du as pi j of u, and if I again let u equal to t, then I can write it as a pi j of t. So with that, I can write the variance. Okay, variance is equal to, yes, hope I am there. I am connected. People are there with me. Hello.
Yes, sir.
Yeah, because I'm a little bit slow with respect to this write up. So I said n naught by 2. Hope able to understand what I'm saying. 0 to t. Okay. So I said it is n naught by 2, 0 to t, pi squared, that is pi j square of t, I can write, right? Yes, is that fine with respect to the previous this one? After applying the shifting property, I said I can write integral 0 to t pi j of u into del of t minus u into du as pi j of u. If I substitute u equal to t, then I can write as pi j of t. So by substituting that, I am writing the variance is equal to n naught by 2 into integral 0 to t pi j square of t into dt. Yeah, right. So what can I write further? What is integral 0 to t pi j square of t into dt? Yes, I think this people should be able to say what it is. It is equal to 1, right?
Energy.
So I can say no, integral 0 to t pi j square of t into dt is equal to 1, we say, because here I equal to j, right? So they are not orthogonal. Yeah, it is having unit energy. Okay. So sigma squared xj means the variance. Okay, variance will be equal to what I got. It is n naught by 2. Variance is equal to n naught by 2. Okay. So far what I have done is I found the expression for the mean and variance. Okay. I think this has been asked many times. Okay. Derive the expression for mean and variance of the output of the correlator. Okay, they will ask a derivation. So I think you should be able to tell this much. I think mean is easy. By finding the variance, little bit you have to use your basic knowledge of about the autocorrelation function and shifting property. That's all. Okay. So let me call this as equation 12. Okay. So shall I write for all j? Okay. Fine. So I said, how do we characterize the output of the correlator is by finding its mean and variance, I said, right? So I came to know that the mean is Sij and the variance is n naught by 2, right? So all the correlator outputs, what we denote that by capital Xj, right? With j is equal to 1 to n, 1, 2, 3 and so on up to n, have the variance equal to what? Which is equal to n naught by 2. So which is nothing but the power spectral density of the noise process W of t. Hope I am clear. I repeat once again, all the correlator outputs Xj, where j is can vary from 1 to n have a variance which is equal to the what? The power spectral density, which is n naught by 2 of the noise process W of t. Yes or no? So we know that the white noise is having a power spectral density of n naught by 2. So that will be the variance of the output of the correlator. Right? What is the mean of the correlator output, which is equal to Sij? Okay. So after knowing these two values, we need to prove here that uh, the random variable, that is output of the correlator xj, are statistically independent. Okay. So the Gaussian random variables, if they are uncorrelated, then we say that they are statistically independent. Yes or no? If we prove that the Gaussian random variables are uncorrelated, then we say they are statistically independent. Okay, then how do we do that? How do we prove that xj and xk are, means if I take two variables with a different this one, we need to say they are mutually uncorrelated. How do you, is it possible to say what if I find what parameter with respect to that I will be able to say they are mutually uncorrelated, and then I will be able to say that they are statistically independent. I heard about covariance. Yes, I'm asking you people. I've heard about the term covariance. Hello? Yes, no response. Is it disconnected or what? So it is there, but people are not talking. I'm asking, how do we prove that the output of the correlators, right? Means I said the basic function pi j of t form an orthonormal set, right? That xj and xk are mutually uncorrelated. If they are mutually uncorrelated, then we say they are statistically independent. Okay. So how do we prove that? I said that can be done by finding the covariance of those two variables, that is xj and xk. Fine. So let me just find the expression for covariance, and how do I say they are uncorrelated? So whatever I'm supposed to write in words, I'm not writing because you know the difficulty. Just I will dictate. Please have a note of this. The basic function pi j of t. I hope you are noting this. The basic function pi j of t form an orthonormal set. Okay. Then xj and xk. So I'm taking here two variables. One is what I said xj, and another one is xk. So these are the two random variables at the output of the correlators are mutually uncorrelated. Okay, are mutually uncorrelated.
So
Yeah,
can you repeat the basic function?
yeah, I will just repeat. The basic function pi j of t, the basic function pi j of t form an orthonormal set, right? Means the value of j can vary from 1 to n, I said, right? Means I'm taking two sets. That is, one is pi j, xj, and another is xk. Okay, so these are the two random variables. They are mutually uncorrelated. Uncorrelated. Okay, they are mutually uncorrelated. If they are mutually uncorrelated, then I can say they are statistically independent. Okay, to prove that these two random variables are mutually uncorrelated, I need to find the covariance of these two variables, these two random variables. I'm asking, are you aware of the term covariance? I did not get any response. That is why. Covariance. I think you might have studied all these things in your maths also and as well as linear algebra also. Variance, autocorrelation, covariance, right? Yes, studied or not studied? Hmm? So no response. Okay, fine. Let me say covariance. I denote that by COV. Okay. So the covariance of these two random variables will be defined as xj, xk. Okay. Uh, okay, xj, xk. So we know what is variance. So now to find the covariance, so it is E of I can write it as first one as what? Xj minus mu, that is variance, right, of the random variable xj. Okay. Similarly, I can write for the second random variable as what? Xk minus the mean of that, mu xk. Okay. So just substitute the value of here. What is the mean of the random variable? We know, right? Xj. And similarly, we can write the mean of the random variable xk. So, is it possible to say any one of you? What is the mean of the random variable xj? Yes, quickly. At least this is the known answer, no? Yes, the mean of the random variable xj. So far, we have derived that.
Yes, Ij.
Yes, I say. Why others are not responding? Yes, I say. Similarly, for xk, I can write its mean is sik. Is that fine? Okay. Yeah, by substituting again xj as what? Sij plus wj. What happens here? Minus Sij plus Sij will get cancelled. Only wj will be left out, right? So similarly, here if I substitute xk in the same way what I am said now, uh, for xj I am substituting Sij plus wj, right? Then I said plus Sij and minus Sij will get cancelled. Only wj will be left out. So in the same way for other variable also, right? So if I substitute um, xk as sik, right, plus wj, then plus sik and minus sik will get cancelled. Only wk will be left out, right? Hope understood that point. Yes, I'm asking. I'm not writing that step. Just I'm writing directly. I'm skipping years. I said no. The value of xj is what? Sij plus wj, right? If I substitute that here, minus Sij plus Sij will get cancelled. Only Wj will left out. Similarly, if I substitute xk as Sik plus Wk, then minus Sik plus Sik will get cancelled, only Wk will be left out. So with that, I can write here only Wj and then Wk. Yes, hope got this point. So now
Yes,
you,
sir.
now you write the value of Wj and Wk. So we know how to write the expression for Wj and as well as Wk. So that is integral 0 to t, right? For Wj, I can write integral 0 to t w of t pi j of t into dt, right? So let me write here. So I will start from here because I need to write the integral, so it takes some more space. So I can write e of, okay, so e of, so wj I said it is integral 0 to t w of t pi j of t into dt. So, so it is what pi j of t into dt. Okay, similarly for another one, what I said, write another integral, it is 0 to t. So for wk, I can write it is w of u, okay, then pi k of u, into du. Okay, so you close the bracket. Yeah. So again, what I need to do, interchange the expectation operator and integral, right? So if I do that, what I can write by interchanging the order of integration and expectation operator. So any one of you can say, just now we have done that, right? Interchanging the order of expectation operator and integrator. So I can write first two integral terms, that is 0 to t, right? Then integral 0 to t, you write pi g of t into pi k of u. Right? So pi j of t, then pi k of u. Okay. Then what I can write e of, so I'm skipping here one more step. If I write e of, that is w of t, w of u into dt into du, that you are supposed to write, right? So I can replace that e of w of t, w of u as what? The autocorrelation function. Okay. So shall I write rw of t comma u? See, I'm skipping one step here, I'm saying, okay. Is that fine? Yes, sir. My dear students, is that fine? I'm said. What I said, interchanging the order of integration and expectation operator, we can write integral 0 to t, right? Pi j of t, pi k of u into expectation of w of t, w of u into dt into du, right? I said the expectation of w of t, w of u can be written as the autocorrelation function. That is rw of t comma u. Then what I said, we know what is rw of t comma u, which is equal to n naught by 2 into del of t minus u, right? Hope noted, na? Yes, if I move, scroll up, is it fine? Hello? Yes, is that
Yes,
fine? I'm
sir.
asking. Yeah. Okay. Then if it is done, then what's the next step? I said you just substitute the value of rw of t comma u as what? N naught by t into del of t minus u. Then apply the shifting property and simplify it. So I will write that. So just I'm writing the value of n naught by 2 outside the integral, and let me write the remaining term, right? So that is 0 to t, then integral 0 to t, okay, then pi j of t, pi k of u, pi j of t, then pi k of u, okay, then del of t minus u dt into du, okay, dt into du. So again, after applying the shifting property, that is integral uh, 0 to t w, that is pi k of u del of t minus u into du can be written as pi k of u, and if you say u is equal to t, I can write it as pi j of t, right? So which is nothing but I can write here. So after applying the shifting property, I am writing, right? So n naught by 2, n naught by 2, okay. So integral 0 to t, 0 to t. The first term is what? Pi j of t, pi j of t, okay. The second term, what I said, if I substituted integral 0 to t pi k of u del of t minus u into du can be written as, I said, pi k of u, right? If I let u equal to t, then I can write it as pi k of t. Is that fine? Pi k of t, okay, into dt. Just let me. Pi k of t into dt. Okay. So here, based on the value of j and k, we say what is the covariance, right? So when j is not equal to k, if j is, see, you are able to understand this now, integral 0 to t pi j of t pi k of t into dt. Now is it possible to say when j is not equal to k, what is the value of this integral?
0.
0, right? So when j equal to k, this integral value will become 1, right? So with that, I can say the value of this covariance will be equal to 0 when j is not equal to k, and the value of covariance will be equal to n naught by 2 when j equal to k. Okay, so I think with that it is fine. Yes, yeah. So I will just write the covariance. Covariance will be, you write that covariance of xj comma xk, which is equal to 0, right? So when j is not equal to k, when j is not equal to k, and its value will be equal to n naught by 2, right? When j equal to k, when j is equal to k. So let me call this as equation 13. So this is the expression for covariance. Okay. Just have a note of this. I can say the random variable xj, where the value of j can vary from 1 to n, are uncorrelated. Okay. So as I said, if the Gaussian random variables are uncorrelated, then we say they are statistically independent. Fine. So I think let me stop with this. So let me continue further the process of the conditional probability density function and other things. So with this I will stop here. Okay, I repeat once again, here the random variable xj is uncorrelated, right? And we say if the Gaussian random variables are uncorrelated, then we say they are statistically independent, right? So with what value of mean and variance? The value of mean is Sij, right? And variance is n naught by 2. Is that fine?
Sir,
Yeah.
what about innovative, sir, for internals?
Yeah, innovative, I told na yesterday, I will be asking about the uh, what I said, the time domain procedure of expressing